Hi there, Mr. Sutton here, bringing you the Algebra 2 10-7 Part 1 homework solutions on using trigonometric identities. In this one, we're focusing on identities involving reciprocals and also the Pythagorean identities. So for all of these problems, I'm going to be going through my little APAC mnemonic way of remembering what to do in what order. So I always check first to see if there's any weird angle identities going on, and here there aren't. We just have x. The p was Pythagoreans. There's no squared trig functions, so on to the next. Algebra, there's nothing I can do algebraically with these. So it comes down to the c, cosine and sine. Turn everything into those. Secant I can turn into 1 over cosine. Cotan I can turn into cosine over sine. And once I do that, I notice algebraically here that I can cross cancel these cosines. So that leaves me then with 1 over sine of x, which I can turn into cosecant of x just to get a single trig function that's not a reciprocal, and that's as simplified as this gets. For this problem, thinking through my list of things that I try in the order I try them in, I first noticed that there's some squared trig functions going on. So, I mean, that would be a Pythagorean kind of situation almost, only we have a single term on each side of the fraction instead of two. So I think we don't really need to go the Pythagorean route on this one. Instead, let's try turning everything into sine and cosine and see what happens. So cosine squared I'm just going to leave as is. Cotan squared is actually cosine squared over sine squared. And now algebraically I can same change flip to divide by this fraction here. So I'm going to multiply the cosine squared in the numerator by sine squared over cosine squared from the denominator. Once I've done that, I notice I can cross cancel these cosine squareds. So that leaves me with sine squared for my final answer. So for this problem, the first thing I notice in terms of things I'm looking for, I see a squared trig function in here and a 1 minus. That looks like one of those Pythagorean identities just waiting to be used. So we have the identity sine squared plus cosine squared equals 1. If I subtract cosine squared from both sides, then I have 1 minus cosine squared, which is this pattern, equaling sine squared. So I can replace this with sine squared from this identity. And once I do that, I also notice that I've got a cosecant over here. I can turn that into 1 over sine of x. And then one of the sines here can cancel with the sine down there, leaving me with just sine of x. On this problem, just thinking through my list of things, I don't have any squared trig functions, so I'm going to try some algebra as my next step. I can definitely multiply these parentheses together, and this is an a minus b, a plus b situation, so I can use a squared minus b squared to multiply this out quickly. So that's going to be cosine squared minus 1 squared, or just minus 1. Now, since I have a squared trig function at this point, I'm going to try one of my Pythagorean identities. We've got one that says cotan squared plus 1 equals cosecant squared. So with this identity, if I subtract 1 from both sides, that'll give me this pattern of cosecant squared minus 1 over here. And then on the other side, I would have cotan squared. So I can just replace this whole thing then with cotan squared, and that's as good as it gets. This problem is a little bit tricksy. So thinking through my list of things, Pythagoreans, we've got some squared trig functions, but they're just kind of their own terms and their own fractions. So it doesn't really make sense to use one of our identities at this point for those. Algebraically, that's my next thing I'm thinking about. I could merge these fractions together. Then I'd have something like tan squared minus sine squared all over sine squared tan squared, but that seems like it possibly creates a bigger mess than it solves. So that leaves me with cosine and sine. I could turn this tangent here into sine squared over cosine squared, and then same change flip and have cosine squared over sine squared. So then I could actually merge these fractions together. There is actually a faster way though, so that way would work eventually. A faster way, you actually could do this. These are both reciprocals already. So what if we just replaced them with the things that they're reciprocals of? What if I turn 1 over sine squared into cosecant squared? What if I turn 1 over tan squared into cotan squared? So if I did this, then one of those Pythagorean identities would actually be very helpful. We have the one with cotan squared plus 1 equals cosecant squared. And if I subtract cotan squared from both sides of this, that'll give me my cosecant squared minus cotan squared pattern that I see here. And on the other side of the equation, I would just have 1. So I can actually replace this entire thing with just 1. For this problem, there isn't anything we can really do with Pythagorean identities or algebra. All we can do right now is just turn all these into sine and cosine. So cotan, that's cosine over sine in my numerator there. And cosecant I'll rewrite as 1 over sine of x. And now I'll do same change flip to divide one fraction by another. So we've got cosine over sine times sine of x over 1. Once I do this, I notice I can cross cancel these sine of x's. So that just leaves me with cosine of x. For this problem, I notice I have a squared trig function in the denominator. So I'm thinking a Pythagorean identity might help here since it's a 1 minus sort of situation. So I've got sine squared plus cosine squared equals 1. That's one of my identities. And if I subtract cosine squared from both sides, I see that 1 minus cosine squared, like I have here, is the same as sine squared. So I can substitute sine squared for this expression down here. Now I can cancel out one of the signs in the denominator with the sine of x in the numerator. So I'm left with cosine of x over sine of x. And just to turn that into a single trig function, cosine over sine is cotan of x.